Sorry about that break in the video, guys. So we'll just go through and finish up these examples. Yeah, so we were on number 6 last time when the video stopped, and we did 25 to the negative 3 halves. Went through rewriting the 25 to the negative 3 halves as a fraction to get rid of the negative exponent. Remember, fractional exponents are radicals, so we can rewrite 25 to the 3 halves as a square root of 25 to the third power. Take the square root of 25, which is 5. 5 to the third is 125, so we have 1 over 125. Or, and I'm not sure if this came through in the last video or not, we can rewrite 25 as 5 to the second power. That raised to the 3 halves, do your power to a power, and we multiply 2 times negative 3 halves. That gives you negative 3. That's going to be 1 over 5 to the third power, which is also 1 over 125. So either option is fine there. Like I said, knowing these powers to know is going to come in very useful. So if I know not only the 5 squared is 25, but the 25 is 5 squared, I can rewrite some things. We take a look at number 7, then we'll just go through these. I'm going to do these over to, this one I can do here. 64 to the 2/3 is a cube root of 64. That's the second power. Remember, denominator becomes your index, numerator becomes your exponent. 64 to 2/3, you can do your factor tree if you want to. You're going to end up getting 4. Or if we know that 64 is 4 to the third power, that's another way to get 4 also. And we have 4 squared, which gives us 16. Or, again, we can do 64, rewrite that as 4 to the third power. Three times 2/3 is going to give us 2, and 4 squared is 16. We take a look at number 8, the 9th root of 8. Let me do that one over here. The 9th root of 8. And this is one where instead of writing the fractional or rational exponent as a radical, we're going to rewrite the radical with a rational exponent. So remember, index is our denominator. Exponent, which isn't written, is a numerator. Now this is where knowing your powers to know is going to help. We know that 8 is 2 to the third power. So we're going to rewrite 8 as 2 to the third. Exponent stays the same. You know, if power to a power, we're going to multiply. So 3 times 1/9 is going to give us 3/9, which is 1/3. So 3 times 1/9 is 1/3. So we end up with 2 to the 1/3 power. And then we can rewrite that as a cube root of 2. Either one of those would be fine. Depends on the directions. Sometimes the directions will say write it in simplest radical form, in which case you would use 2 cubed. If it doesn't say, this is equivalent also. 2 to the 1/3 is 2 cubed. Number 9, the cubed root of the square root of 27. We'll do this one over here also. The cubed root of the square root of 27. So same thing with the number 8. We're going to put this into fractional exponents or rational exponents. So the square root of 27, we'll take care of that first. That's 27 to the 1/2 power. So just rewriting the square root of 27 as 27 to the 1/2 power. But then we're doing the cubed root of that, where the cubed root of something is the same thing as raising it to the 1/3 power. And now we have 1/2 times 1/3. that gives us 1/6. And you could make this then the 6th root of 27. But when you do a factor tree, nothing will come out. So this is actually going to be easier to use the powers to know. 27 is 3 to the third. 3 times 1/6 is 1/2. We have 3 to the 1/2. Same thing as a square root of 3. Again, either one of those is fine. Depends on the directions. Simplest radical form. If it doesn't say anything, you can leave it as just 3 to the 1/2. All right, 3 more. Number 10, the 4th root of the square root of 81. 4th root of the square root of 81. We go through this a couple of different ways. We know that the square root of 81 is 9. So we can make this the 4th root of 9, but then we're kind of stuck because a 3 comes out, or a 3 doesn't come out because we're looking for sets of 4. So what we can do is make this the 4th root of 81 to the 1/2 power. And then if we're doing something to the 4th root of something, that's the same thing as raising something to the 1/4 power. And 1/2 times 1/4 is 1/8. We can rewrite 81, if you go to your powers to know, we can rewrite 81 as 3 to the 4th power. And then 4 times 1/8 is 1/2, or 3 to the 1/2, or the square root of 3. We could also do that from the 4th root of 9. We can rewrite this as 9 to the 1/4 power. 9 we know is 3 squared. And 2 times 1/4 is 1/2. You end up getting 3 to the 1/2. Same thing as the square root of 3. So again, you have a lot of different options with these problems. It's really a matter of personal preference in terms of what you'd rather do with these. Looking at 11 and 12, here we're multiplying, number 11, multiplying two radicals. And in order to multiply radicals, the indexes have to be the same. And in this case, we have an index of 3, index of 6. So with radicals, there's nothing we could do here. That's as far as we could go. We could try to break down 16 in both cases, but then the indexes still would not be the same, so we still could not multiply. Same thing with dividing. This is one of the big benefits of rational exponents. It lets us do things that we could not do with radicals. So let's do this here. This is going to give us 16 to the 1/3 power times 16 to the 1/6 power. Now think back to your properties of exponents. When you're multiplying and the bases are the same, you added your exponents. We're going to do the same thing here. We're multiplying. The bases are the same. So we're going to add our exponents. So if we do 1/3 plus 1/6, you need a common denominator. So we'll turn 1/3 into 2/6 plus 1/6 gives us 3/6, which is 1/2. So this gives us 16 to the 1/2 power, which is a square root of 16, which is 4. So something that we could not do with radicals before, because the indexes are not the same, we can do and actually get a nice neat answer, but we can do with fractional exponents. Same thing with number 12. We can rewrite the cube root of 9 as 9 to the 1/3. Again, with radicals, we couldn't divide these because the indexes are different. Square root of 3 is 3 to the 1/2. Again, think back to your properties of exponents. When you divided, you subtracted your exponents. We're going to do the same thing here. We're going to do 1/3 minus 1/2. We're dividing. Oh, but you know what? Our bases aren't the same, so we can't do that yet. But what we can do is rewrite 9 as 3 squared to the 1/3 and 3 to the 1/2. That gives us, if we raise our power to power multiply, 3 to the 2/3 over 3 to the 1/2. And now the base is the same, we're dividing, so we can subtract the exponents. 2/3 minus 1/2. Need a common denominator, so we have 4/6 minus 3/6 gives us 1/6. So when we subtract 2/3 minus 1/2, we get 1/6. We get 3 to the 1/6, or the 6th root of 3. Again, either one of those would be fine. Depends on the directions if it's asked for simplest radical form or not. So again, that's it with fractional exponents. This will take some time to practice. Just remember, fractional exponents are radicals. So whichever you feel more comfortable with, working with radicals or using your properties of exponents, either one of those is fine. Again, I'll put this out in OneNote. I'll put this answer key with all the examples out there. Remember some stuff over here as well to look at. But again, this powers to know. You'll have access to this. Always, I'll put out one that has a completed table also. I'll add that in here as well if you don't want to do the table yourself. But again, the better you know these, the easier this entire section becomes, especially moving forward. That's going to help as well with that. So, again, hope you were able to follow this video. If you have any questions, please let me know.